We are on the page 29, section 4.4. We are going to talk about another concept. It's called slope. So let's figure out what do we mean by slope in math, right? For the first one, let's see how we are going to define it. So usually, how would you describe a slope? If you ski, snowboarding, then you would say, oh, the slope is steep. Or you go hiking, oh, you say, oh, it's hard to climb up because, it's steep, or it's easy to climb because it's flat, right? So we will describe the slope is what? Is the steepness of a line, right? But for math, what we would do, we will give everything a number, right? So we have to start it from the beginning. We will give somebody a 0, right? What kind of things you think we will give it a 0 for a slope? What do you think? We will say, okay, if it's flat, we will call this one is what? The slope, we use n. Okay, we say, okay, slope is 0. Then we have to give something, a slope is 1. We have to start it from 0 and 1 for everything, right? So where is your 1 you think it would be? We say, okay, how about in the middle? Okay, so 45 degrees, we will give you a slope called what? 1, right? Then, where do you think would be the half? How about halfway? So halfway, we'll say, okay, this is a half, right? What do you think of where it would be 2? So we say, okay, this is 1. How about twice as much that much? We call it 2. Okay, that's how we started. So if we have 1, we must have what? -1. What do you think the -1 would be? Would be opposite of 1, right? It will be halfway here, then we call it what? -1. Where do you think that would be -half? Would be this way or that way? So it would be shallower, would be what? Half that much. So that would be your -half. And -2 still same way, but steeper, right? That's how we started. And so we started the slope this way. And if it's a flat, we say the slope is what? 0, right? If the slope goes up from the left to right, then we say what? The slope is what? positive, right? If it goes down from the left to right, then we say the slope would be what? Negative, right? One of them we didn't talk about is what? Parachuting. So if you are free falling, do we talk about slope? Not really. So if it's a vertical, we say the slope is what? We say undefined because there's no such a thing or doesn't exist. Okay, that's how we start the slope. And we talk about more formally how we form the idea. So if it's a steeper, you will go higher and then walk over. So we start from 1. 1 means what? You will go walk up 1, right? And run over 1. If it's 1-to-1 ratio, we call that slope is 1. If twice as much, that means what? You need to walk up 2 steps and run over 1 step. That would be what? You will be twice as much, right? So, formally, we do this way. That one explains the concept first. And formula is this way. We say the slope, right? Slope m, we use m, equals what? How high you climb up and compare how far you go on the flat, run over, right? So we say slope is what? Rise over run. So it's the same thing. When you rise, it means what? Changing in y compares to the changing in x. Okay? And we can also write this way. And the point on the slope, any point, right, would be x and y, right? And to differentiate them, for first point, we use subscript. Then x1, y1. Then second point, we use x2, y2. Okay? So the rise would be what? The difference between the y. So you will do what? y2 minus y1 compares to the changing in x would be x2 minus x1. Or we can write it as y1 minus y2 over x1 minus x2. They are the same. We will see some examples on those. Okay? And let's take a look what it actually is. So if I have 2 points, -1, -2, and 2 and 4, what do you think my slope would be? So you just graph them. Where is your -1, -2? So you go left and right first, then you jump up and down, right? -1 and -2, that would be here. Would be in the 3rd quadrant, right? Where's 2 and 4? 1, 2, and 4. 1, 2, 3, 4. It's right here. 2, 4. That would be on the 1st quadrant. So, what do you think the slope would be? So you do rise and run, right? So you rise 1, 2, 3, 4, 5, and 6, right? Run over how many? 1, 2, 3. Is that right? Let me see. 2, 4, -1, and -2. Right? So your slope will be what? Rise 6, run over how many? 3. So that will be 2. Will that be correct? Yes, because the slope is what? Going up from left to right, so it's positive. Right? Let's look at the second one. It is what? -1 and 5. And 2 and -3. So we'll look at it. Where is the -1, 5? -1 and 5. 1, 2, 3, 4, 5. Right here. -1, 5. Right? Another one is where? 2 and -3. 1, 2, -3. 1, 2, 3. 2 and -3. Right? So the line looks like this. So what do you think? The slope is positive or negative? Negative, right? So how about slope is rise over run? So you don't go up from point 1 to point 2, you come down, right? So you come down how many? 1, 2, 3, 4, 5, 6, 7, 8. So you come down -8. Then you run over how many? So 1, 2, and 3. Right? So your slope should be what? -8/3. That's how you see the slope. Either positive or negative, but sometimes will be what? Flat, 0, or undefined, a vertical line. Right? Let's look at the next one. -2 and 1, 3 and 1. So that will be where? -2 and 1 will be here, right? -2 and 1. Where is 3 and 1? 1, 2, 3 and 1. 3 and 1. What do you think? The line, the slope will be what? Flat, 0, right? If you look at the next one, if you have 4, -3 and 4, 1, then let's see, what do we have? We will have, take a look, so 4, -3, 1, 2, 3, 4, 1, 2, 3. 4, -3 here is here, 4, 1 is here, right? So what happened to your line? It's a vertical line, so your slope is what? Undefined. Or you can say doesn't exist. So, have some idea, right? Let's practice some more and take a look. Next part. So, look on your page 4.4 handout. Let's see. Okay, on your page 27. Let's take a look at those. To identify the slopes, positive, negative, 0, or undefined, then compare two different slopes. Okay, if we have one is like this, and line 1 is this, line 2 is this, right? So we say, which one has the greater slope? Which one is bigger? What do you think? This one? 1, right? Because this is a positive, this is a negative. So in next one, if you have things like this one and this one, this is line 2, this is 1. Which one is a greater number? 1, right? Because 1 is a positive, 2 is what? 0. Then look at your page 28. So you have 1 like this, and you have here. Then it's asking you about the slope of each line. So you have 1 point, you marked 1 point there, 1 point here for you. So what do you think? We said slope is what? Rise over run. So look at this one. It's a positive or negative? It goes up, so it's positive. So this one is 3, right? And here is what? 1, right? So you climb up how many? 3 steps. Run over 1 step. So it's what? 3 over 1 is 3. And next one, we have the graph looks like this. Then it gives you 2 points, right? Why it's here is what? -2 and 1, right? Then another point given would be what? -2 and -2. So what do you think? So -2 and 1, this is what? 2 and 2, right? So your slope is positive or negative? It goes down, right? So it goes down, it means what? The slope is negative, right? So that's C. It comes down how many steps? So 1, 2, 3, right? Run over how many steps? 1, 2, 3, 4. So it's negative 3/4, right? And next one you have is this way, 1. So what do you think the slope is? Flat. So the slope is 0. Then we are going to skip the bottom one. Okay. And let's get back to your page 29. So what did we just talk about? We talk about how to identify a slope, right? Either going up, positive, going down, negative, flat, the slope is 0, and vertical line, the slope is what? Undefined or doesn't exist, right? Then let's take a look. Something called slope-intercept form of the line, okay, of the equation of a line. So we are going to do something more, and so we have 3 examples here. First one, y equals 2x plus 3. Okay, second one, we have what? Y equals 2x minus 4. And third one, we have y equals 2x. Okay, let's use different colors. So, to graph them, then let's see what's the situation. Okay, so for the first one, we are going to graph on the one graph. Okay, so for the first one, we are going to do t-table. Okay, 0, 1, 2. So you plug in x0, 0 plus 3, 3. X is 1, y is 5, x is 2, y is what? 7, right? So we have 0. We have 0, 3, and 1, 5, and 2, 7. So that's our first line, right? Then for the second one, let's take a look. We just use t-table to graph it. So 0, 1, 2. So you plug in 0, that's -4. Plug in 1, that would be 2 minus 4, -2, right? And next one, oh, not this one, is this one. X is 2, that would be what? 0. So that would be what? 0, 0, -4, right? And 1, -2. 1, -2. 2, 0. So we have a line like this, right? Then let's take a look. Another one, the third one, it says what? X and y, x is 0, 1, 2. So you plug in x, y is 0, plug in x is 1, y is 2, 2 would be 4. That would be what? 0, 0, and 1, 2. 1, 2, right? And 2, 4. So your line will look like this, right? What happened to all those lines? They are parallel. Is that right? Then let's check on their slope. Slopes in something called y-intercept, right? Let's take a look. So for the first one, the slope will be what? Rise over run. Rise over run. 2 over 1. So that would be 2, right? Where is the y-intercept? Right here. 0, 3, right? 0, 3. It's a 3, right? Then let's look at the blue line. And what's the slope? Rise over run, right? Then rise over run. It's what? 2. The y-intercept is what? Here, -4, right? So that's 0, -4. It's on the -4. And let's look at the orange line. So what's the slope? Rise over run. Rise 2, run over 1. So it's 2, right? And what's the y-intercept? It's what? 0, right? 0, 0. It's on the 0. Y-intercepts. Talk about intercept by what? Y-axis. It's a y position, right? So let's see, try to organize the patterns. So we are doing pattern recognitions right now to see what do they have similarities and what's the differences there. So the slope is 2. Take a look. Are those all 2? That corresponded to what? The slopes, right? And take a look the intercepts. Here is 3. Is this a 3? Right? Here is -4. Is this a -4? This is 0. Is that same thing as your +0? Right. Okay? So, what we are saying is this. When you write a certain way, like this, okay? If you look your page 30, that's how we write. And we call it what? Something called slope intercept form. Okay, so if you write it this way, if you write what? Y equals mx plus b. If we write it this way, you can see, right? First one, y equals what? 2 plus 2x plus 3. So this is your what? Slope position, right? And here will be your what? Y-intercept position. So if we write y equals mx plus b, so for each linear equation, we will have what? Y and x. Sometimes you miss one, right? Then that would be special cases. But usually if you have both y and x, it means what? It's a slant line, right? So if you write a y by itself, then something x plus some number, it means what? The first one, the coefficient before the x, it would be what? M is your slope. Then B will be your what? Y-intercept. That means 0b. Right? So it looks like this way. That's your x, y-axis. Then if you have a line cross over the both x and y axis, the intercept position on the y-axis, that's your y-intercept, right? Then anything, any point on the line, the ordered pairs will be the points on the line we call x, y, ordered pairs. Okay, so this form you will use a lot the rest of your algebra life. All the way to what? Pre-calculus and calculus. We'll all use those. Okay? So far we have learned several forms, right? First one is what? Standard form. Have we learned that? For a linear equation, we write it in what way? Ax plus by equals c, right? And not the a, b both be 0 because it will be gone. You will not have a linear equation. One of them can be 0, right? A, b, c are some kind of numbers, right? We'll call it real numbers. Okay, then a, b cannot both be 0. Right? That's the standard form. Now we learn another form, we call it what? The slope intercept form. which will be written as what? Y equals mx plus b. Okay? M is your slope. B is your what? Y-intercept. Right? So we start to learn different forms of what? What kind of things we are talking about so far? Linear equations, right? That means when you graph them, you will have a line. Is that right? Right? So, we are learning different forms of the linear equations. Okay? Now, so we introduced the concepts. Then we identify them next. So you will look we are on the page 30 and identify the slope and y-intercept on each line. So if we have this one, so identify slope and y-intercept, right? So do I have a linear equation? So do I have a slope-intercept form? Yes. If I have slope-intercept form, it means what? You have y by itself. The x and number are on another side. Then the coefficient in front of x, that will be your slope, right? Then the number will be your what? Y-intercept. That will be 0, 3. Right? Then that will be the first one. Second one, if you have 5x plus y equals 2. So do we have a linear equation? Do we have, what kind of form is that? It's this one, right? Standard form. It's not slope-intercept form. So you cannot tell the slope and y-intercept. So what do you need to do? You will change the standard form to the slope-intercept form. And the slope-intercept form is saying what? Get y by itself. Then, how do we do that? So, you do the opposite. Take the x away. So you have y equals what? Negative 5x plus 2. Right? Now, do we have a slope-intercept form? Yes. Then we can write down the what? Slope and y-intercept. Then you know this slope is positive. It goes up, the line goes up. This one is negative, the line goes down. Right? So you learned two forms. Which one gives you more information? The slope-intercept form, right? Because it tells you, besides the slopes, it also tells you what? Where the point will be intercepted by what? The y-axis. Okay? Next one. So for this one, do we have a linear equation? Standard form or the slope-intercept form? It's a standard form, right? But to tell the slope and y-intercept, we need to do what? to change the standard form to a slope-intercept form by moving the x away, right? So we have this. Is this a slope-intercept form? Not quite, because for a slope-intercept form, you have to get y by itself. You still have -4 there. So you have to multiplying, so you have to do the opposite by dividing. So what do we have? Y equals 3/4 x minus 1, right? Do we have a slope-intercept form now? So you can tell the slope is what? 3/4. So write 3 round over 4, right? Then your y-intercept will be what? 0, -1. Right? Let's look at the next one. Okay, so we just did what? Identifying the slope and y-intercept, and for the given equation, right? Either in a standard form or in a slope-intercept form. You will all change them to what? The slope-intercept forms to be able to identify those, right? So all those, you have what? Both x and y's. So it would be a slant line, right? Then let's look at some special situation, special cases. Okay, so first one, if you have what? Y equals -1. Just has y, no x. No x, x is running free left and right? For x to run. So your graph will be what? Like that. X, y is what? -1. So it's like this. Right? So it's a horizontal line. It's not a slant lines anymore if you have special cases. Either would be horizontal line or a vertical line, right? So what do you think your slope is and y-intercept is? Slope would be what? Horizontal line, slope is 0. What's your y-intercept? So that would be what? 0, -1. Right? Another one, you only have x. X equals, say, 5. You don't have a y. And y goes up and down. So your line should be what? A vertical line, right? So that's your x5. So y goes up and down a vertical line. So for the vertical line, what's your slope? You can say either undefined. Sometimes you say it doesn't exist. So that's your vertical line, right? Then what's your y-intercept? Does it intercept by the y-axis? No. So you don't have a y-intercept. Right? So, what are we doing? We are learning what? The slope of a line, right? At the same time, we learn what? We have learned a slope-intercept form. We also talk about special cases as well. right? Okay, let's see. Next thing we are going to talk about is this. Determine two lines, either they are parallel or perpendicular or neither. So two things, two lines. Lines are basic phenomenons in our world, because if we look at the light, they go straight, right? So it goes like a line. And so we see how two lines are related to each other. So they might be what? Parallel, they might be perpendicular, or neither, right? Why we care about the parallel line and perpendicular lines? Because for railroads, you better have parallel lines, right? So the train can go smoothly. It's important. And for perpendicular lines, why they are important as well? Look around in your room, how many perpendicular things happened. Even you can see, right? Like the board on the corners, they are perpendicular. When you build a house, they are perpendicular, right? Or your, anything around you, a lot of perpendicular things. Why it's important? If you build a house, the foundation, if you don't do perpendiculars, then they will fall. It will not be stable. So we want to, when we design something, if you want to make it stable, then you will graph the line perpendicular way, right? So then how do we decide two lines are parallel or perpendicular? Okay, so this way. If two lines are parallel, it means what? They have, how's the slope? Slope will be what? The same, right? For those. Then what kind of lines they are perpendicular to each other? So if you look at the basic things, so we say this is what? Slope is 1, right? If it's a perpendicular, it will be opposite side. It will be here. So what's the slope? Would be like here, right? The slope will be what? -1. So if you multiply these two slopes, 1 and 2, if you multiply these two slopes, that will be what? 1 times -1, that would be what? -1, right? If we have a line like here, m equals 2, then where is the perpendicular line to this blue line? So it will be here or here? It will be lower, right? Like here. So the slope will be what? Negative halfway. This is twice as much. This will be half as much, right? So this is the third one, the fourth one. If these two lines multiply together, so what do we have? 2 times -1/2, it will still be -1. Okay, so if two lines are perpendicular, it means what? when you multiply these two slopes, the result will be -1. If they are the same, it means they are parallel, or they are overlapping each other, right? Or another one overlapping each other. So, situation like this. Perpendicular ones, when you multiply the slopes, that would be what? Would be -1, right? Okay? So, let's see some examples to decide how those things work together, how two lines work together. If you have first one, y is -5, 1 plus 1, 2x plus 10y equals 3. So, what do you think? You have to decide by what? The slope of the lines for both of them. So you have to decide what's the slope of this one. This one you can tell, -1/5, right? How about this one? You cannot tell right now, right? So you need to change the what? Standard form to slope-intercept form. Get y by itself. So what do we have? 10y equals -2x plus 3, right? Then you divide it by 10. What do we have? Y equals -1/5, x plus 3/3, 3/10, right? So the slope is what? -1/5. So what do you think? These two lines will be what? Parallel, right? Let's look at the next one. X plus y equals 3. X plus y equals 4. So for the first one, what's your slope? Change the standard form to the slope-intercept form, right? So your slope is what? -1, right? Then standard form, change the slope-intercept form. So y is what? X plus 4. What's your slope? The coefficient in front of x, 1. So what do you think? Are they parallel? They are not the same, so not parallel. But when you multiply them together, do you get -1? So they are what? Perpendicular, right? So, next one. Let's see. What's the slope? So change it to slope-intercept form. We have what? Y equals -3x plus 5. So the slope is what? -3, right? Then this one, we will change the standard form to what? The slope-intercept form. And get y by itself. So what do we have? Y equals -2/3 x plus 2, right? So what's your slope? -2/3. Are they parallel? No. Are they perpendicular? So you multiply them, actually it's 2, right? So not -1. So they are not parallel, they are not perpendicular, so they are neither. So we use what? Slope-intercept form to decide the slope of a line, right? The slope of a line. Then we can see how two lines behave to each other, right? Are they related in a certain way? Parallel or perpendicular or neither. Right? So think about it, what we are learning in this section. The slope of a line, right? Is what? Rise over run. Then if flat, slope is 0. Going up, slope is positive. Going down, slope is negative. Go vertical, slope is undefined, doesn't exist. Right? So also we learned the slope-intercept form. Get a y by itself. Y equals mx plus b. Also, we use the slope-intercept form to decide what the line, what the slopes of the line would be. Then we decide how two lines related to each other, whether or not they are parallel, perpendicular, or neither. Are we good? So that would be your section 4.4.